Okay, so I'd like to talk about the logic side of the ontology called record in context. So we talked a lot about that already, and I will try to take a specific different angle to the same problem I talked about during the workshop. First, I would like to talk about the ambition of record in context, because I think it's important to point out what they're trying to do here. So we talk about the International Council on Archives that is developing this ontology called Records in Context. We are now at the version 1.0.2, and here are some excerpts from their presentation page. RiC-O, I'm going to talk about record in context ontology as RiC-O, like we often do, provides a generic vocabulary and formal rules for creating data sets that describe in a consistent way any kind of archival record resource. It supports publishing RDF data sets as linked data and making inferences using the logic of the ontology. It also says RiC-O is a technical implementation of record in context conceptual model that includes formal logic. It is a generic domain ontology, a high-level framework. So it's important to understand how ambitious the project is, right? Because the idea is to completely and formally define, like we do in mathematics, the domain of archival description. And it's a very large domain. We'll talk about that. Maybe uniquely large, if you think about it. So it's much more, and I really want to emphasize that, it's much more than a useful tool for archival description or search or reasoning, right? It is a formal and normative description of what archives and records are, what they are, right? It's supposed to be a definition. So if you cannot recognize in it what they are, then there is a problem. Important question is, what is the truth criteria behind an ontology? How can you actually judge if it's correct or not? And here I think mathematics can help us. So I'm going to be inspired here from Haskell Curry in '51, who developed he wrote an outline of a formalist philosophy of mathematics, and I think that can help us put some concrete definition on all of that. Imagine you have a whole world of statements, possible statements. A theory is going to be a class of true statements that we're going to call theorems. So statements are, I don't know why my, okay, there it is. So a theory is going to be a subclass of statements that are true. So that means the statements in our world of statements are going to be either true or false with respect to a theory. So you're going to have to bring a theory to be able to say if a statement is true or false. And that actually really nicely fits the idea of context in record in context. A theory really provides a context to determine the truth of a statement. A theory is deductive if it is an inductive class. That means if you can actually get to some theorems from more basic theorems that we call axioms. It's decidable if it's definite class. That means you can actually find a way to get all the theorems in the theory. And it is consistent if it doesn't exhaust all the statements. That's kind of a strange idea, but when you think about it, if the theory really encompasses all the statements, then there is no more theory. It's inconsistent. So whenever you have an inconsistent theory, you can really prove anything. And it's complete if it is incapable of a consistent axiomatic extension. I'm not going to talk much about that. It's actually a very strong requirement. Some of you probably have heard of the theorem of incompleteness of arithmetics by Kurt Gödel. It's actually related to, it's actually what it is. Having a complete system is not always the case. It really means that anything that is true for that system will be provable. An interpretation of the theory, and this is the important part for us, is going to allow us to connect that theory to a subject matter, like archival science. So an interpretation of the theory is a relationship between statements of a theory and what we call contensive statements, I mean the statements that corresponds to them in the real world, of the subject matter, like archival science. So we say that in this case we have an interpretation of the theory in the subject matter. Okay, subject matter is given from experience. We know things about archival science, about records. We know things. We do, and the community agrees on some things. But now the question is, does my theory, is it actually an interpretation? Do we have an interpretation? That means do we have a match between those two? In our case, we're going to be interested in a theory that is consistent, decidable, and deductive, and I'll talk a little bit more about that. So the interpretation is said to be full as opposed to partial if there is a contensive statement for each statement in the theory. It means that each statement you can build in the theory has an equivalent in the subject matter. All of them can be mapped to something. And in our case, it's going to be the case. The correspondent contensive statements are called interpretants. So the interpretants are those statements in the subject matter that corresponds to a certain statement in the theory. So, for example, an interpretant of a physical theory, a theory in physics, may have, an interpretation of a physical theory may have an interpretant which can be experimentally tested, right? So usually you're going to try to build a theory in physics in such a way that statements that correspond to that theory can be tested so you can verify the theory is correct, right? An interpretation is valid when the interpretant of every theorem is true. And in everything I have here on the left in the theory being a subset of statements that are all true, right? It's a set of theorems. It's built in such a way that all the corresponding interpretation in the subject matter, the interpretants, are all true, okay? And then we say that an interpretation is adequate if, yeah, there you go, that's better like that. An interpretation is adequate when every statement whose interpretation is true is also a theorem. So it's the other way around. That means that what is true in archival science, you're going to find also in the theory that goes with it. And we talk about an acceptable theory when the interpretation we are using is both valid and adequate, and also the theory fits the purpose it's built for. Okay, so that's kind of the background. Now I want to try to apply that to the problem of recording context and archival science. So if we try to use the examples from the recording context ontology. So a recording context is indeed a formal theory. We use RDF as a standard, but it could be something else, but RDF are formal files. The subject matter is archival description, and we have statements and theorems. So here are 3 examples, and I'm using that kind of formal way of describing, but there is really no ground behind that. One is to say that an activity documents a record resource documents an activity, and an instantiation documents an activity. Well, only, I'm missing my, there you go. Well, this is not, I made it in PowerPoint, and I think when it's using the Google slides, it's slightly modified a little bit. But the theorems here are the 2 latest statements. So the first one is incorrect. An activity doesn't document record resource. Does it mean that it's not a statement? No, it is still a statement. In my language, I can have that. But it's a statement that is outside of my theory. It's somewhere here, right? So it's not a theorem. However, the 2 others are theorems. A record resource documents an activity, and an instantiation documents an activity. Or at least in some world, I can assume that these are theorems. That means they are true. Now, RiC-O is both consistent, decidable, and deductive. That's very important for us. We want a consistent theory. That means that you cannot deduce anything from the theory. That means the theory somehow isolates a subset of true statements. If it is inconsistent, it's going to collapse with that larger circle, basically. Because when you have an inconsistent system, you can deduce anything. So if you have P and not P true in a system, you have an inconsistent system. And logically, when you have P and not P true at the same time, anything becomes true. Okay? Anything can become true from those two statements. So we want a consistent system. The good thing about using RDF and OWL is that OWL allows you with what is called the reasoner. So when you can use it in the Bergier application or with other means, but there is a reasoner attached to it that allows you to check at all time if your system is consistent. So it is possible, it's rich enough that you can build an inconsistent system, right? You can create some rules and some relations that are such that it's inconsistent, but it will tell you. It will tell you. So you can at all times decide if it, make sure it's consistent. You cannot create something that is undecidable. That's very important. It's always decidable. OWL always gives you an answer. And that's really what is powerful with those tools, is that you cannot end up in a situation where your system is so complex that you can never have an answer. If you take any programming language, because it's Turing complete, you will always have the possibility of never having an answer, right? So if you say, oh, I'm going to program my ontology in Java, great. You're going to have much more freedom than in an OWL. But there is no guarantee that your program will ever return a result. You might end up in an infinite loop. And it's actually very likely you will at some point. OWL is a safeguard. It's a guardrail. It says there's something you can do, but there's something you can't do. And it gives you a framework such that everything you express always in a decidable space.
So what is OWL?
Sorry, Ontology Web Language.
Thank you.
Yeah. It was developed at the time of web semantics, where people were trying to develop a web that is kind of like a big graph. So it was very popular in the late 90s, early 2000s. It's kind of went down in popularity from this perspective of web semantics, but it's still incredibly popular among ontologists because it's really the most powerful tool we have to describe ontologies. I would say along with maybe TypeDB and a few others like that. But it's kind of a major standard for describing rich ontologies. Thank you for the question. Please ask questions.
You have been interrupted already. I will continue the interruption. You said it is not true that an activity documents a record resources. Well, unless the activity is archival description, because that's what it does.
Well, we're going to get to that. Yes.
Okay,
Thank
good.
you. Thank you. Thank you very much. Yeah. I'm always intentionally putting out there bold statements to create reaction and be corrected so that it creates interaction. That's great. Please keep interrupting. RiC-O is also deductive. That's also the whole point. We have the reasoner that is able to make inferences. So when you say documents is the inverse of is documented by, you don't need to give the information of what is documented by what. Automatically, if you say X documents Y, and you ask with a Sparkle query, what is Y documented by, it's going to answer you X, even if you didn't put it in the system. It's going to deduce it. I'm giving here a very simple example, but there are richer examples. And I think, in my opinion, insofar as those reasoning capabilities can be pretty powerful and advanced, we can talk about AI system here, right? I think we can improve them, and that's part of our studies role, but that's not the topic right here. Interpretation is full. There's nothing you can say in RDF within our world of recording context that doesn't have a meaning in the real world. So it's full in that sense. Now let's talk about validity and adequacy, because I think that's where things start to be interesting. Validity, all theorems have a true contensive statement, a true interpretant. Yes, I mean, insofar, if you look at what can come out of recording context, and that's usually how it works, you develop a theory where you look at it and everything that you can build from there has a true statement on the side of the subject matter. Adequacy is all consensive true statements of archival size correspond to a statement that is a theorem. That is not the case. So one of them is actually more difficult to achieve and verify. Any idea which one is more complex? Which one is more problematic between validity and adequacy? Do you have an idea? There's one that is fundamentally harder to achieve. Adequacy, yes, yes. Yes, because adequacy, you start from something that is intuitive. We have a general understanding of archival science. I mean, you guys do, I don't. But of how things come together, and we want to try to match that to a formal theory. The other is much easier to say, I have my formal theory, and given the way it's built, everything in there is true in the real world. So yes, we have validity. Do we have adequacy? And kind of the mistake, the common mistake is to think because I have validity, my system is good. But that's not true. You can have a very, very small set of things that come out of your system that are true indeed, but it's missing a lot of things. And that's why I would like to talk about adequacy a little bit. So RiC-O, valid but not adequate. A record can document an activity. That's what RiC says. And that's true. So RiC says that, and that's true in the real world. But then the real world can answer back, yeah, but I want an activity to have a record as its object. So I'm just talking about, that's exactly what Luciana was talking about. What about an activity that is about a record? Like I'm going to create a record or use a record or search or access. Well, if I look here, I put an excerpt of everything that has a relationship with activity. There is nothing like that. An activity is linked to a record only insofar as a record creates an activity in the whole theory. So here we have a problem. We have a true statement on the side of the subject matter that says, well, an activity should be able to have a record as its object. So in the case of use, create, etc. But it's not the case. So that is a problem of adequacy. I'm taking another example. The physical location has coordinates. That comes from the theory. If you look at the theory, you can deduce that physical location has coordinates. Fine, that's true. But isn't a physical location a place? I don't know, maybe it's not. But intuitively, I would think it is. Well, if I look back at the theory, physical location is not a place. It's not true. It's not a true statement of the theory. So we have two examples here of things that intuitively make sense and are true, but don't find their equivalent on the side of theory. And I think there are many other examples like that. So we have a whole, like, the red is like a hole in the subject matter. There's a whole range of true statements that don't find their equivalent in the theory.
I say something.
Yes, please.
By saying physical, you say it is a place.
Mm-hmm.
If you just say location, is location a place, then you can say may not be. But physical location is etymologically a place.
It is not a place?
It is a place.
Yeah,
Physical
yeah,
is a place.
That's what I think. I mean, intuitively, I would say a physical location. Regis campus is a physical location. Well, if it's a physical location, it's also a place. Yeah, no, that's typically an example. But you see how it's interesting that if you say, so those things are subclasses of thing. You say, hey, in our ontology, we need physical location. Yes, everybody's gonna say yes, that's true, we need that. We need place, yes, everybody agrees, we need place. Well, okay, so that's true. Physical location should be a thing, place should be a thing. Both of those are true. Both of those are true, and that contributes to make the theory valid. But now you look from the side of what are all the true things about those things? Well, a physical location should be a place. But if you look back at the theory doesn't say that. It's not a theorem of the theory. It's a theorem that an instantiation, no, here, that's a mistake. Don't look at instantiation because that's something I changed.
Because the location can be conceptual, doesn't need to be physical.
Exactly.
Yeah. Well, and maybe one thing that is missing here is a distinction between location and physical location, for instance.
Logical, conceptual.
So I'd like to talk about this idea of adequacy. In general, it is difficult to achieve, okay? An acceptable theory is built through a back and forth between the subject matter and the formal system. So you have kind of circle going on here when you build a theory. And it's usually done by working on a partial set of true statements within the subject matter. So you're going to take a partial set of true statements, you're going to build the theory, you're going to go back to the true statements to see, do I have completeness? No, I need to improve it, and so forth. It's actually, this process itself is related to a fundamental problem, is how does a formal system relate to intuition? And we can wonder, well, if it's easy to get validity but really hard to get adequacy in general, can you actually achieve adequacy? And the answer is yes, absolutely. There is no essential limit to, there is no essential problem in achieving it. It is just more difficult and more work. But if we assume a general agreement in the community, even on a subject that is not entirely formal, like archival science, if we assume, and I think, if we put everybody here in a room and say, hey, let's agree on a system. Might not be the best, but we agree on the description of archival records, we could reach, without any problem, adequacy of the system by just tweaking things in a way that works. And I'd like just to touch on the example of the church steering thesis, which is a really interesting example of adequacy in a very, very broad topic, which is computation. The idea is to say, hey, can we create a model of computation to describe what computing is and what it can do and not do? And several people worked on that same problem in the 30s and reached the same conclusion independently from different systems. And they said, whether we take that system or that system or that system, they all describe and define the idea of algorithm and computation, in a sense. There are different systems. They are all equivalent. We can prove that they're equivalent. But the difficulty still resides in the fact that you cannot prove that this is adequate. You can see it, you can show it, you can give evidence, but you cannot prove it. Why? Because essentially, the intuitive notion of a computation, of what it is to take a piece of paper and do some computation by hand, this intuitive notion that we have since, I don't know, the Greeks and before, it's still an intuitive notion. You cannot rigorously say, well, that intuitive notion equals that formal system I built. But you can have enough evidence and enough people to say, yes, it does. I cannot prove it, but it does. So in this area that is very broad and complex, we reached adequacy through what we call the church steering thesis. That means this thesis that says, it's not a proof, it's not a theorem, but we say, hey, this is the definition of computation. And in the same way I say, well, there's no reason you could not say, hey, that's the definition of archival records. So what's the problem with RiC ontology? The problem I would like to propose is that the domain is too large. Okay, that's as simple as that. It's not necessarily, there might be a problem on agreement in the community, but I think that's only a first step in the problem. The larger problem, because the agreement, the people who in ICA who came up with that, they agree with each other. So that's not in itself a problem. The problem is that the domain is too large, because archival sense domain, if you think about it, is everything. And I think that's one of the difficulty, is that, well, there is a subdomain having to do with specific archival management, right? But in the end, you don't want an ontology that doesn't talk about what the records are about.
No.
It's records in context. You need the context of the records. And the context of the record is the whole world in the whole history of humanity, potentially. So,
It's life.
what?
Instead of saying everything, we can say it's life.
It's life, yes, yes. Yeah, I mean, in some sense, maybe, yes, maybe everything is a bit large because, well, you know, I was going to say maybe some faraway galaxy is not concerned with a record, but you never know. I mean, if a record has to do with NASA, you know, capturing some waves or something like that from the cosmic universe, that doesn't. So the thing is that eventually, when you say record in context, the context can be everything, and so that is very, very large, and too large to be tackled as one domain. That's kind of the proposition I would like to push forward. If we try to do so, we risk ending up with a laundry list like this. I think that's a laundry list. So that's the current latest version of record in context. Instantiation, agent, concept, coordinates, date, event, extent, physical location, place, record, resource, relation, role. These are all the first degree things, I mean concepts, under thing. It does look like a laundry list. And I think that's because it's just so hard to tackle everything at once. And by doing that, if we end up with a laundry list, basically just sitting on the table and say, okay, what are the things? Well, here we came up with those 5, 6, 7, 8, 9, 10, 11, 12 things. But they look so arbitrary. And the reason they look so arbitrary is because, again, if we sit and wonder what are the things we talk about in recording context, we attack a domain that is way too large, and that's confusing. So an idea is to divide and conquer, and then we end up missing adequacy, like I said. So divide and conquer, we can divide in two different fundamental ways. Two theories can be completely distinct and independent from each other, or one can be what Curry calls an axiomatic extension of the first one. Okay, so we're going to say that the theory C extends A, or the theory B extends A. So the domain themselves should be treated in a rigorous order. You cannot just stop anywhere. Even if you divide, you have to be very consistent in your way of approaching that problem, and starting with the most general, the core. So in this case, we would start with theory A, and because theory A would contain all the first primitive notions. Okay, so I already talked about that during the workshop, but very quickly, for those who were not there, primitive notions are the axioms of the ontology. They are the building blocks that are necessary to derive all the notions. So I've presented here different ways of getting to those primitive notions. You can find them by thinking, okay, what are my either relationships? So that's the most obvious one. If you have X is a Y, then Y is going to be more primitive than X. But has a kind of like attribute style relationship also gives you an idea of what is primitive. An event has a date. Event is going to be more fundamental and primitive than date. Okay? And physical location has a coordinate. Physical location is going to be more primitive. By doing that, we can slowly abstract from our laundry list a smaller subset of concepts that are the basis, and we can focus on them and just write a high-level ontology with just them. And then we can extend it. And RDF, OWL will have no problem doing that. You can have a RiC high level, RiC1, RiC2, RiC3. And you put them all together, and then you can query. But the RiC one is going to be independent, it's going to be very high level, it's going to be all about the fundament, and then you tackle only that. And you create something entirely consistent in that, where you don't need to bother about coordinates. You should not have coordinates in a high-level ontology. You should not. There's no reason. You can talk about tons of things without wondering about coordinates. So another way to detect primitive relation is to replace, to say the sentence, I can conceive X without Y, but not the other way around. If you can do that, then X is more primitive than Y. I gave a few examples here, but the point here is to really kind of distill a first range of primitive notions that are going to constitute my high-level ontology, and focus on that first. Completely make abstraction from the rest. And that way, we could build a general schema with only the most. So here is an example of what I think could a general schema look like. You could have just five elements: agent, date. Well, I wanted to remove date. Agent, event, place, record, resource. Maybe that's the only four they are at the top level. And you can create a whole ontology with relationship, everything with just those four. It's going to be already very rich. And there's probably more than those four. Yes, Tracy.
How would you bring in other ontologies? Some systems have their own ontologies, so they would be records in and of themselves, no? And
yeah.
How would that fit into your
you just
things?
Yeah, they have to fit. So they're going to be extension of that one. So you're going to then create another ontology where you subdivide place into the kind of place you can have in that sub-ontology. But it's going to not be a problem at all. If you use the same terminology, it's going to be just a series of RDF files. So you're going to have an RDF file with that one and another one. You see what I mean? No?
I do. What I'm saying is digital twins, spatial ontologies, et cetera, they all have their own thing in their own systems and subsystems and their own databases.
Yes.
So how would all of their stuff come into the archive and be captured with your schema?
It's already the intention of recording context to be a high-level ontology that is going to which you're going to plug your more specific ontology, where because you're in NASA, you need the category called, satellites, whatever. All of those things are going to be, but precisely, I think that's also missing in recording context, because I took the example the other day of activity type, where they anticipate you creating some instances of activity instead of saying, well, we're going to have subclasses that we're going to create of activity. We're gonna prepare something where people can just add their individuals. And I think maybe one of the mistakes of recording context is to think, well, people are just going to add individuals to it. They're going to use it directly with just individuals, not with concepts and classes. But I think fundamentally the idea here of that kind of arc is to say, from the very beginning, you think of ontology as building blocks of abstract classes that can be plugged to each other. So that even the person who arrived with their own archival department, their own problem, their own ontologies, they can plug their ontologies. The same way we've plugged our ontologies when we built RiC-O and said, hey, we have our super high level, then we have a common sense schema, and then we have archival science schema that come together. Well, you're going to have your archival domain, specific domain schema, coming together as well. But in every time, these are concepts that come, so they are always extension of the theory. They have to be consistent and compatible. But there is no reason, if you build your high-level one well, any ontology of anybody should be compatible. It should always work. Yes?
So I want to go in the opposite direction. I have a very strong prejudice from decades of building systems.
Yes.
And in building whatever system it was, I and people I was working with would start from a premise. Any model is not a model of reality. It is a perspective on reality. And RiC is very much something that has its own context. And it can't tell you what a record is because it's only looking at what I need to describe about a record. It's not telling you what I need to know to appraise a record, what I need to know to preserve a record, to intellectually manage a record that's under my control. And it doesn't even acknowledge that there are different contexts of description. In the US, the common assumption among archivists is that description is effectively synonymous with finding aids. But there's another context in which description is a basis for asserting authenticity. So authenticity is a binary value, but an assertion of authenticity is a belief statement. So a description that addresses concerns of authenticity, with RiC-O doesn't really at all, is going to give you a basis for saying, I believe this is or is not authentic. And that would be a very different ontology.
Is there a context where you don't need agent?
No.
No. No, right? There is none. And I'm saying let's push that question as far as we can to build those higher level such that any ontology from any archivist in the world can match that. And then you can have modules that are more specific. So you could imagine at some level going a little bit more specific and say, this is going to be public records kind of ontology specific. This is going to be space exploration, whatever. But I think there's so much work that can be done on the top level where we can just deal with the things that you will always, always, always need.
But
and you put them in such a general way that everybody will want to use it that way. Yes?
But that top level should be archival science, not description. Description is subsidiary to archival
Yes,
science.
that's a good, yeah, you had.
I kind of want to have you unpack the dependency piece of this in the context of like dispositive and probative records. So a probative record would be something created to document an act that has occurred. But a dispositive record would be one that in its completion actually constitutes the act happening, like a marriage certificate.
Oh, yeah.
Or no, that would be probative. No.
Like a contract.
A contract. A contract. So the act doesn't exist until both parties sign and it's done, and,
yeah.
And the record is made. So in terms of dependencies, would it be that obviously in the probative case, you'd have the act would happen and that would then generate the record, but in a dispositive case, could that be reversed? Or is the schema flexible enough that could be?
I mean, that's really interesting. I mean, I think to describe that kind of complex interaction between the act, the activity, and the record, you can build a high-level schema that is going to be rich enough that you can see those connections between action and record. I mean, there is a whole theory of illocutionary act that talks about that. You know, like a judge says, "I condemn you." This is a performative act. I mean, because this is performative language. Like by saying the thing happens, like marriage, and so but that's typically a good example of if you have the right theory at a high level, but you're going to have to abstract. To do that at a high level, you're going to have to abstract completely from the case of records and action and marriage and notary. You have to think very abstractly and say, okay, an act can create a record and a record can create an act.
Okay.
And those relationships exist, and they exist even outside of the world of archival description. And you have to think somehow outside of that world to build that high level, and then the thing downstream are going to match those structures that you created, if that makes sense. Sorry, yes, I think I'm...
We're running out of time.
Yes,
You can,
okay.
No, finish up. You've got a couple of minutes.
Oh, okay,
Yeah.
that's, So this kind of describes the kind of dependency you could have between different blocks. And again, all those blocks are all kind of like sub-theories on which you work on. So they are like little recurring context ontologies. They are all their own ontologies. And then only downstream, you're going to actually have your individuals. But here I'm not even talking about individuals. I'm not even talking about populating the ontologies. I'm just talking about concepts and relationships, okay? My last slide is just like I did during the workshop. I think it's important because we talk a lot about AI and machine learning to say that we're on a completely different world here because we're talking about a theory as having this very strong truth connection with the real world, right? Through this idea of interpretation I talked about. We're not having an empirical perspective here like machine learning does, okay? It's not probabilistic, it's not statistic, it's not because a whole bunch of things happen, we can guess that this is gonna happen again, okay? We're really at a formal level and data can help us see some patterns emerge. So I would say you could use machine learning to try to get some intuition of the theory, but in some sense, at the end of the day, it is a purely human activity. There's no way around thinking what is, particularly in a context where the definitions of records in their context is entirely in our minds here of a community. There's no way around getting around the table and thinking, what is it fundamentally, what are the definitions, and how do we formalize them? That is completely other world different than machine learning. That's it. Thank you very much for your attention and your question. Love the interaction.
Thank you.